Problem 3. As shown in the figure, what is the area of the shaded portions? So it's this pink spot right here. Before continuing any further, I like to quickly talk about these 3 shapes you see. So in this problem and the next, we will be looking at some more complicated geometric shapes and finding their areas. And usually they're going to make up like this. So first, do you think this is so there's this orange shaded portion. This is 1/2 of the whole rectangle. As you can see, it cuts from one diagonal to another diagonal. Over here, you'll be surprised to find that this is another 1/2. Why though? Suppose we draw a line through here, and that we know that that's 1/2. Now you'll see that the orange portions in this left half is 1/2 of this whole part. So is it on the right one? So if we add these together, the orange part is also 1/2 of the whole rectangle. Now, this one is a bit trickier. So if we have a shape like this, how do we know if it's 1/2? What we can do is cut 1/2 like this, and then you see that this bottom part is just the exact same thing as number 2, and this top part is just the same thing as number 2, but flipped around. So each of these orange parts is 1/2, and if we add them together, then in total they'll be 1/2 of the whole rectangle as well. So just take a moment to think about these 3 shapes, and we'll be moving on to the problem. Got them in your head? Okay, let's look at this. As shown in the figure, what is the area of the shaded portion? So these 3 numbers are the 3 areas we know. As you can see, this portion is just a random quadrilateral, and it's encased inside this rectangle. So the very first step is to identify which one of these shapes it is using. If you look closely, you'll see that it's actually made up of 2 of these. The first one looks like this. So the first one looks like that. And the second one, right, that's the shape, looks like this. So looking at these 2, it's really just these 2 overlapped on top of each other. And we're just trying to find this shaded portion that they overlap on. So we know that this part right here is 1/2 of its rectangle. This part right here is also its 1/2. And how come I know this one? It's because if you flip this around, it's really the same thing as the other one, just a bit taller. So which one should I use? Maybe I can use both. So first I know that there is A and there is B. And I can use this over here. So I know that this portion is 25 plus B. This left side is 42 plus A plus 17. And this shaded part I'm gonna call that S, because S is for shaded. Now over here, I know that there's this shaded portion right here. And what I know is A plus S plus B is the same as all of this is the same. All of this is the same as 42 plus A plus 17 plus 25 plus B. Why do I know this? Because if you look at A, S, and B added together, it's really this portion right here. And of course, we already know that these two halves added together is equal to 1/2. Each of these are 1/2, which makes them equal. And we're trying to find S. Notice how I was able to use both of these. I first separately draw them, and then I was able to use both of these. Now, how do we find S? Well, I know that I see A and B on each side of the equation. So if I add them, so I could just cancel them out, and then S would be equal to 42 plus 17 plus 25, which makes S equal to, we're just going to add this all up, 42 plus 17 is equal to 59. 59 plus 25 is equal to 84. So the final area for S is 84.